Day 104. Just like a linear regression, a trend line or line of best fit for a quadratic function can give us a look at data. We can use our calculators to generate lines of best fit so we can make predictions. So, let's take example number 1. I'm going to look for points that go exactly through the corners of the boxes. So there's one, there's one, there's one, there's one, there's one. Okay, -1, hold on, let me start over there. -4, -5, -3, 0. -1, +4, +1, 0. Okay, I have a table. So now I'm going to show you how to run a regression using my Desmos calculator. So first thing I'm going to do is I'm going to add a table. I'm going to start typing in my numbers. So -4, -5, -4, -5. I'm going to type in the next one. -3, 0. -1, +4. 1, 0. Okay. I'm going to zoom out on my graph a little bit. Notice it plotted out my points for me. So I need to ask it to run a regression for me. Standard form for quadratic equations is always ax squared plus bx plus c. But I have to establish a relationship in between y1 and x1 because that's where I put in my data. So I'm going to say y1, and I'm going to put this little symbol. That tells my calculator that I'm trying to run a regression. Ax squared plus bx plus c. Oh, I forgot to put the 1 after the x. Notice that up here I have x1, y1. So I also have to call them x1, y1. My calculator is very specific. So it gave me an equation. y1 equals -x squared minus 2x plus 3. Okay, let's try this guy. Example number 2. I'm going to go ahead and type in this data into my calculator again. I'm going to turn off these guys. I'm going to start here. I'm going to add a table. Under my x's, I'll put time. They always put the x's at the top. Okay, so now I'm working with y2, x2. I'm going to zoom out a little bit. And it looks like I can't even hardly tell what kind of graph this is. But they told me that it was quadratic, so I'll just go with that. y1, this little tilde, ax squared, x1 squared plus x1 plus c. Enter. And, oh, excuse me, this was supposed to be y2 and x2. All right, there we go. So, if we notice, my r squared is real close to 1. That means this is a really good match for this graph, okay? And I see all of my values. So I'm going to go ahead and I'm going to write those down on my little table here. So f of x equals negative, I'll write it below because I'm kind of running out of space here, 15.82x squared plus 44.56x plus 4.04. That's my approximate equation. What is the best estimate for a height of 2.7? Excuse me, a height at 2.7 seconds. So that means they want me to plug in x equals 2.7. That's a lot of math. Instead, I'm going to come here and I'm going to go ahead and type in, and I'll just call this f2 of x equals, and I'll copy my equation, negative 15.8182x squared plus 44.5636x plus 4.03636. Okay. So now I have an equation. I'll turn this guy off. I don't need any of that anymore. And I need to find out whenever x equals 2.7. So I need f2 of 2.7. And it's 9.04. All right, next one, height of 12 feet. They want f of x to be equal to 12. So 12 equals the rest of my equation. Well, that's a lot of math, right? So what I could do instead is make it all equal to 0. I'll just move my 12 over, and it'll be all my equation minus that number over there. Let me plug it in. So this will be my current equation minus 12. And I look at just my x-intercepts. It's either going to be 0.192 seconds or 2.6525. Well, let's go ahead and also compare this over here. So I'm looking for, when is it reaching a height of 12 feet? So I'm going to trace. Oh, look at that. It's also 0.19 and 2.62. Same exact thing I saw as my x-intercepts. So if they tell me that, and I want to plug in a number for y, I just say the equation minus whatever that y value is, and that'll give me my answer. Okay, so it's going to be at 0.19 seconds and 2.62 seconds. Let me go ahead and get this out of the way. Oh, excuse me. It said to reach. So that means the first one. So that one's the answer. So, what is the best estimate for the time it takes after the ball is thrown until it hits the ground? So, it's going to go up and then it's going to come back down. Let me look at that equation that I got from my regression. So it started here at approximately 0, 0. It went way up there and then it came back down. And this y-axis is how tall it is. I want to find out when it'll hit the ground. So I'm looking for its x-intercept, and it looks like it's approximately 2.9 seconds. Because again, my football started here, it went up, 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 up. So it started here, it went up, and then it came down, and it hit the ground right there, 2.9. So again, all this is just interpreting data.